You are holding something that can kill you in less time than it takes to read this sentence. A few drops. No smell, no taste, no warning. It doesn't care if you're the hunter or the hunted, the healer or the enemy. It kills anything it touches, indiscriminately, without mercy, without exception. This is poison. And at some point, tens of thousands of years ago, a human being looked at this substance, the same substance that had just killed someone they knew, and decided the right move was to pick it up. Not bury it, not fear it. Pick it up and point it at something else. That decision, whichever human made it first, turned one of nature's most efficient killers into the deadliest weapons upgrade in the history of our species. Every poisoned arrow, every venom-tipped spear, every toxin ever weaponized by a human hand traces back to that one impossible choice. So how did we get from, "This thing kills whoever touches it," to, "This thing wins my wars and feeds my family"? And more importantly, why would anyone be reckless enough to start that process in the first place? Let's deal with the obvious problem first. Poison should be the last thing early humans ever wanted anywhere near their tools. There was no antivenom, no hospital, no way to reverse a mistake. A scratch from a poorly handled applicator, a contaminated water source, a moment of carelessness while grinding up a toxic root or scraping venom from a frog's skin, and the person preparing the weapon could become its very first victim. Every early human who worked with poison was handling something that didn't distinguish between friend and enemy, hunter and prey, careful hands and careless ones. It killed whoever it touched. And the people using it knew that better than anyone alive, because they had almost certainly watched it happen to someone else first. There was no reason to expect this relationship would ever be worth the risk. And yet, independently, in multiple parts of the world that had zero contact with each other, humans decided it was. That's not a small decision. That's choosing to keep a loaded, unpredictable threat in your own hands, on purpose, forever. So where's the actual proof this happened, and how far back does it go? The strongest and most specific evidence comes from a site called Border Cave in the mountains between South Africa and Eswatini. Excavations there uncovered a wooden applicator stick dated to roughly 24,000 years old, and residue analysis on that stick revealed traces of ricinoleic acid, a compound that comes from the castor bean plant and one of the most effective natural poisons available in that environment. Ricin, the toxin derived from castor beans, disrupts the body's ability to manufacture the proteins it needs to survive, and even a small dose delivered into the bloodstream can be fatal. Finding that residue on what looks unmistakably like a tool built specifically for applying poison to a weapon tip pushes the origin of deliberate chemical warfare at the individual hand-to-hand level back tens of thousands of years before a single word was ever written down. But researchers studying this question, including archaeologist Marlise Lombard, who has spent years analyzing Southern African stone and bone tools for use-wear and residue evidence, have been careful to point out how difficult this case actually is to prove. Organic residues degrade over tens of thousands of years. A stain on a 24,000-year-old stick could theoretically come from something else entirely: a resin used to haft a blade, a plant processed for food, a natural dye. The case for deliberate poison use rests on a combination of clues stacked together: the specific chemical signature, the shape and function of the tool itself, and direct comparison to poison use practices still documented among some Southern African hunter-gatherer communities in more recent history, where toxic plant and insect compounds are ground down, mixed with a binding agent, and applied specifically to arrow tips, never to blades meant for cutting, only to the very points meant to break skin and enter a bloodstream. It's a strong case, built carefully, layer by layer. But like a lot of the deepest history in this story, it isn't one single smoking gun. It's a pattern that keeps showing up in place after place, too consistently to be a coincidence. And that pattern gets stranger the more specific it gets, because completely different environments produced completely different recipes for the exact same purpose. In parts of southern Africa, some communities have historically used the larvae or pupae of a beetle in the genus Diamphidia, whose toxin is potent enough that a dose smaller than the single grain of rice delivered into the bloodstream can kill an animal many times the hunter's own size, not through force, but by slowly shutting down the muscles an animal needs simply to breathe. In South America, hunters developed curare, a plant-based toxin so effective at inducing paralysis that surgeons centuries later would eventually adapt a controlled version of it to use as a muscle relaxant during operations. The exact same biological mechanism that once dropped a monkey out of a rainforest canopy, later repurposed in a completely unrelated context to keep a human being still on an operating table. And in parts of Southeast Asia and South America, indigenous hunters have used the skin secretions of golden poison frogs, animals so toxic that a single frog can carry enough poison to be lethal to several grown adults, delivered simply by wiping a dart across its back.
Here's the part that should genuinely stop you for a second. None of these groups had any contact with each other. No shared knowledge passing between southern Africa and the Amazon rainforest. And yet, the exact same basic insight kept getting discovered again and again, independently, across entirely different continents, different species, different toxins, different delivery methods. That's not a coincidence you can explain away with one invention slowly spreading outward from a single source. That's the same idea getting reinvented from scratch, over and over, because the advantage it offered was too enormous to walk away from once anyone noticed it. A hunter armed with a poisoned arrow doesn't need to land a killing blow. A shallow wound, barely more than a scratch, becomes fatal entirely on its own over the following hours, while the hunter simply waits and tracks the animal from a safe distance, instead of risking a close, dangerous encounter with something that could kill them first. And that single realization changed something fundamental about what a weapon even needed to be. Before poison, the physical force behind a spear or an arrow was the entire story. How hard could you throw it? How sharp was the point? How much raw damage could the impact alone inflict? After poison, that changed completely. A small, light, unremarkable-looking arrow, one that couldn't have brought down a large animal through impact alone, became every bit as lethal as a heavier weapon requiring more strength and a far riskier, closer shot. This is a genuine turning point in the story of human weapons technology, because it's the first moment we can clearly see a weapon's killing power separated from its size and its force. The poison was doing the actual work now. The arrow was just delivery. Now, here's where the story gets genuinely uncomfortable, because the same knowledge that made hunting safer also made humans significantly more dangerous to each other. The written historical record is full of it. Greek and Roman writers describe the Scythians, nomadic warriors from the Eurasian steppe, coating their arrows in a mixture that reportedly combined snake venom, decomposing matter, and animal blood left to putrefy, producing a wound that could kill through infection even when the strike itself wasn't immediately fatal. Some historians have argued this exact practice may be the origin of the word toxic itself, tracing back to the ancient Greek word specifically describing poison used on arrows. Whether or not that precise etymology holds up perfectly under modern scrutiny, the underlying point doesn't need it to be true. The moment humans figured out how to turn a survivable wound into a guaranteed fatal one, that knowledge did not stay confined to hunting animals for food. It became military technology almost immediately, and it stayed military technology in one evolving form after another for the rest of recorded human history. So why did ancient humans do something as reckless as deliberately handling one of the deadliest substances available to them? The honest answer is the same reason behind almost every dangerous technology humans have ever adopted, because the advantage it created was too large to walk away from. A poison that could occasionally kill the very person preparing it was still, in the long run, safer than hunting large, dangerous animals purely at close range, over and over for an entire lifetime, with nothing but a sharpened stick and raw courage standing between a hunter and something strong enough to kill them outright. Once one group figured that out in southern Africa, in the Amazon on the open Eurasian steppe, it was never going away again, no matter how many people the process itself occasionally killed along the way. Ancient humans took one of nature's most efficient killers, something that showed no mercy and no preference for who it happened to touch, and turned it into a tool they carried on purpose, aimed on purpose, and passed down generation after generation as one of the sharpest, coldest, most effective edges our species ever built for itself.